What do you can
Okay, so my name is Abby, and this is my presentation on how to use Excel in the chemistry lab. So if you want to sort of follow along, you can enter these data points into Excel on your Chrome extension or on your desktop app. Is anybody going to do that? Okay.
The ones that don't have computer, welcome. There's computers here.
That's gonna take so long to sign into.
No, it's so far away.
Make it go down. I forgot to put
You select it, and then you go on the green line and make sure that it's like a plus, and then you drag it down to where you want it to be.
Well, thank you. All of you guys Asia?
HL, huh?
I have 4 people in my class.
You have 4 people in your class?
Yeah, besides me.
Like 5 in total?
Yes. You can like take a picture and then follow along.
Or you can download in your phone. You have also Excel.
We have to do it for
Excel
our
on my phone.
AIAs, which, do you guys have Burgess? Your IAs were gonna be fun.
Okay, IAs are so much fun actually. Like I actually enjoy those.
I was miserable. I had to do like 500 basketball shots.
But he said your IM was really good in class today.
Hmm?
He said your IM was really good.
Oh, yeah.
Continue.
Okay, so have you guys entered all the data?
Yeah, I got it now.
Yes.
Okay. So in order to prompt functions, you always have to enter the equals sign. This tells the computer that you're about to enter something that you want it to calculate for you. So whenever you want to use the data of another function that you already have, you always click on it, or you just enter the cell name based on the intersection of the column name and the row number. You can see here that it'll enter 0.014 because I entered B2 into the cell after hitting equals. And then always remember your just basic for function sort of technology language for math. Basically / is division, plus is obviously addition, and so forth. Okay, so in order to find functions, you have to go to the sigma up here. You can see it right here. I'm pointing at it with the red dot if you can't see. And you hit that arrow under and go under more functions, and then it'll pop up with this sort of box that says insert function, and then you go to pick a category and just pick the category that you think that your function is in. So these are just the common ones, sum, average, count. They're basically just straightforward and logical. Here are some common abbreviations for the natural log, the basic log, and a different log base. Any questions? And if you want to go ahead and try, you can put in ln for any of these and then sort of give it a go and see if you know how to enter functions. Okay, so whenever you enter any function, whenever you hover over that cell, you'll be able to see the function in the way that you typed it in. So basically, anytime you use a cell, that cell's name will be in this function sort of row. Any questions about that? Alright, so this is any time you use the data of a cell and not your actual like mathematic just recorded data. So just as I showed you before, using cell B2, if you're using a cell in your formula, then every time that you use that cell in your formula and you copy the formatting, it'll basically drag that formatting down. And I put in an example right here. Basically, if I use the data of the cell to the left of C1 and copy the formatting of C1 down to C7, C7 will also use the formatting of the cell to the left of it. It's basically just using the corresponding cell based on what you had entered in your original cell. Any questions about that? All right. So this will basically just like help you reduce the amount of time that you use whenever you're doing calculations in the lab, not having to do the natural log of like every single one of your data points. And that's about it
Is
for
there
that
like a way to
slide.
like not do that?
Hmm?
Is there like a way to like, instead of like having it like copy the formatting and like transpose it, is there a way to just have like, if I wanna keep that one function and like put that exact same function with all the exact same cells into like another one? Like, how do you do that?
So you want to copy the exact like,
Okay.
so this says B2 and divided by 1.4 times 10 to the 7th. You want that to just be into another one
Yeah.
that doesn't use like any other cell's
Yeah, and then
data.
those exact same cells.
That would just
Would it
be,
copy paste
oh,
basically?
you can hit the format, okay. You enter the function for the first one, and then you go to your next cell, hit enter, and then enter the data or like the result of your first cell, hit enter, and then copy the formatting of that one, so it'll just copy all of that data down.
Okay.
Also, whenever you're doing your X variables, instead of just like typing them in, you can just like create any function that makes sense. So like, this is by 30-second intervals. You hit 30 on your first cell, go to the second cell, hit equals, use the cell of the first one, the data of the first cell, and then hit plus 30. So every time that you format that data down, it'll just add 30 to your previous one, so you don't have to type in 30, 60, 90, and that'll help you with that. Okay, so to create graphs, basically you always need your X and Y values. And in order to do that, you just need to select them and highlight them. So whenever your data is continuous, there's really no problem. You just click and drag. And if your data is like this one and you're trying to sort of compare the X with different Y values, then you're gonna create a non-continuous range. And this is basically when you have to select one row before and then hold down Control and then select your other column. So that's basically how you select non-continuous data. Any questions about that? Okay. So whenever you're creating a linear scores regression line, this is already just assuming that you have created your scatter plot and you want to put your equation and your R-squared value on the chart. So after creating that, you go to Format, which you can get from right-clicking on your graph, going on Format over here, and then clicking the series, and then turning on your trend line. Under your trend line, you'll see Display Equation on Chart, and by the way, this is still on the Chrome extension. It's different on desktop. So basically your R-squared value is your coefficient of determination. This is the decimal representation of a percentage that basically tells you how much variation is explained by your linear squares regression line, and that's how you can see if your line is the best fit. Any questions about that? No? Okay. So whenever you have your graph, you're always gonna have to sort of customize it and format it in order to appropriately represent your data. In order to do this, you go under Format and make sure the bounds are appropriate for the data that you have. And you can also go under Axis Title in order to name your axis, your Y and X axis. Any questions about that? All right. Okay, so this is just general Excel use. You should use this whenever you're having to enter a bunch of data points. Another tip that I didn't put on here is that you can also just memorize your number pad so that whenever you're entering data, you just don't have to look at it and actually just enter it in based on muscle memory and what you see. This really helped me, by the way, on my AP Statistics exam because you're gonna have to do a lot of calculations within a limited amount of time, and having your number pad sort of memorized will help you on your AP Statistics exam if you do choose to take it. Okay, so whenever you're wanting to delete a whole like selection of data, you can't actually just select it and hit backspace. You have to select it and then right click on it and hit clear contents. This will clear everything that you've highlighted plus the white space. If you don't hit clear contents and you actually just select it and hit backspace, it'll only delete the white portion that you've actually selected. This is how you insert rows, columns, cells. You can also just, if you have a right or left, you right click on your column or row. If you don't have that and it's like a Chromebook, you just 2-finger click on the place that you want to go. Okay, so this starts the titrometric curve portion of the presentation. Basically, if you want to follow along, you can obviously enter any of these data points, and this will help you whenever you're doing a titration. And it plots your volume of your titrant and the pH of your solution.
That's great.
This is our lab this week.
Oh, really? It's your lab. I didn't know that you had.
Oh, what math are you guys in?
We're in AP Calc.
Hmm.
Well, actually,
It's not bad. It's because, I mean, if you take regular calc, like IB calc first, then you go into AP. Like, you're taking IB calc?
No, I'm taking AP Calc right now, and I'm taking IB Calc next
it-
year because
oh.
I have to take physics this year, and that's how my schedule just worked out.
You're doing it backward. Oh, I feel bad for you. That sucks.
wait, are you AP Calc online?
Yeah, I'm on
Yes.
FLBS, and then I take a weighted elective.
She didn't want to take biology, so
Oh,
she did anything possible.
I understand.
I guess that's fair. I mean, yeah, that's fair.
Okay.
You didn't want to take bio?
No, so I basically took physics as my SL, and I have to take the second part of my HL math senior year, and I'm taking AP Calc AB this year, and I'll take BC next year because I just want credits.
I mean,
What's
I guess
wrong with
taking
bio?
it online is not too bad.
Bio is just kind of boring to me. So,
Dang.
are you guys alright?
Yeah, I got it.
You were very smart. It's getting me ahead. Like, we're all very smart people, but oh my gosh.
I think bio is boring.
I always love
Okay.
I love bio.
Okay.
It's just motivating.
So basically, for your titrometric curve, this is not talking about your first derivative or your second derivative. Your titrometric curve is the representation, as I said, of your volume of your titrant and the pH of your solution. So you select and highlight all of your data. This is your X and Y. And then you just hit insert, and then you go to the scatter plot portion under the charts category in order to enter this graph right here. This is your titrometric curve. Obviously, this is not a good chart. You have to change your chart title in order to fit your experiment, and also change the axis, change the grid lines, and also create the bounds in order to put your graph in the center. Okay, so this is your first derivative data. First derivative is basically the instantaneous slope at each of your volumes But the thing is, we can't calculate that without having to do it at every single one. So we're gonna find the average, we're gonna find the instantaneous slope at the average between two cell increments. So first we have to find the slope between each of these two. You're gonna find the change in volume and the change in pH. That's what delta means, it's just change. So obviously prompt your function with equals, and then select the second data point we have for volume, and then hit subtract, and then click your first volume point. This is basically just seeing the change between the first and second volume points, obviously. And then you can also go to the change in pH. It's basically the same sort of process. You just hit the second, and then subtract, and then the first.
I have like a technical question, or for you too. How are we supposed to find the derivative of something if it's like the function itself is non-differentiable? Because that's a vertical tangent. Do we just like
Check in the next slide, I think is the graph.
like,
Check
check for
the
the
graph
limits
that you
inside?
obtained.
Okay. So it does have a vertical tangent. However, you can like calculate the instantaneous slopes like approaching them.
Oh, so you just
limits?
get-
Yes,
So that
right
basically
side
you're
by
just
side.
gonna have like
Remember that this is not like a regular function.
Mhm.
This is, you have the data, so you are not expressing the function. Actually, you are calculating over the data, the derivative. So even if you don't see that you have, you're going to see that it has.
Yeah.
And actually, the first derivative is not going to tell you so many things, but the
Yeah.
second derivative is going to tell you a lot.
okay. So that's just how you do your first sort of points, and then we can just copy the formatting. And if you did that, then these are your values. You guys want anything?
You can continue. They are going to figure it out in 1 week. They're going to be trying to find you, but continue.
We'll be crying in a week.
Okay, so now that we have found our data points that we need to derive our instantaneous slopes at each of the average volumes between the two cell increments, we have to find the average volume between those two cell increments. So you're basically just going to use the average function. You hit equals, type out average in all caps, and then this is the formatting for your function. It's number 1 and number 2. It's basically the range in which you want your average to be computed. For this, we're just doing the first two, obviously, because we're finding the average volume between the two cell increments, as I said. And then for your instantaneous slopes, you're just going to use the data that you had previously copied the formatting to, and obviously we talked about that before, and enter the formula that corresponds with your data using the cells that you already have. Hit enter, and then this is what it should be after you've copied your formatting. And this is your first derivative data. It's all good? Okay. So obviously creating a graph, you do the same sort of process. You select your X and Y values, and then you hit insert, and then hit the same sort of thing, scatter plot under charts. And then this is what you should come up with. This is your raw sort of chart after entering. And then you can change the bounds in order to accurately represent where the highest instantaneous slopes are. This is how you find the point. It's around like 19.9 or something like that, I believe.
Yeah.
Or
So the
should be
idea
like
is that
20.
you can
20.
actually you can put many.
Oh yeah, data points.
Exactly, in this axis, and then you're going to be able to accurately
Mhm.
calculate what is the equivalence point of the titration.
In order to enter those data points, anytime you click on a graph, either if it's on desktop or Excel, it's gonna have that little plus icon, and then it's just gonna say data labels, and then you just hit that, and it puts every single one of these on here that is plotted on there. It won't put any that are like in between two data points, because obviously you don't have that data, but you can configure it in a way that suits you best. Okay, so on a desktop, this is how you change the bounds. This is how I change the bounds on my desktop. You go on this chart and double click on it, and then this should put you into the chart design tab. The chart design tab
Do you
is
know how
right
to
there.
change this? Okay, so you can move forward to the second derivative.
Okay, so second derivative. So the second derivative, x values are the same as the first derivative because it's comparing the instantaneous slope. The first derivative is comparing the instantaneous slope between the average volumes. So for this, as you asked before, if you want to just enter these corresponding ones, you just hit equals and then enter that data cell and then hit enter and then copy the formatting down in order to just copy an entire cell. Or you could just select the entire cell, hit Control C, and then copy it right where you want. However, that will copy the formatting of the cell as well. Like the shading, the fill, all of that. And then for this one, we're basically finding the slope of the first derivative graph, the instantaneous slopes of the instantaneous slopes. So you find that by prompting the function first, and then finding the change in the instantaneous slopes of the first two, and divide that by the volume squared. Enter. And then these should be your data points for your second derivative graph.
And then,
And then
cha-cha.
this is your raw chart. It's basically the same way you enter any graph, just as we've gone over before. Change the bounds,
So-
and pinpoint the parts that you would like to actually discover or observe.
So in the second derivative, actually the point, this point here, is going to tell you exactly what is the equilibrium, the equivalence point of the titration. So that's the reason because we make actually, the first derivative is like, but the second derivative is going to give you with accuracy what is the exact point that we have.
So the equivalence point from the first one is like an, almost like an estimation.
Exactly,
And then the second one nails it on the point of inflection.
yes.
So in terms of that, could we just like skip the first derivative graph, do the math for it, and go straight to the second derivative graph?
I think in the guidance that I gave to you, you need to go over the three graphs.
Okay.
And do you want us to get like, do you want us to like attach formulas to the graphs? because we
You
make-
can
or do you
check
want
the
us to-
guidance that I already gave you. This is only a general. This is actually she didn't know the experiment at all. She has raw data that I don't know how do you collect this data, and then she make a trial. She doesn't know anything, so it's only like how to use Excel to do this. Okay.
Okay, so these are the final graphs. This is basically what you should end up with after changing the bounds, putting on grid lines, and labeling your graph. As you can see, I labeled the data points.
Okay.
And that is the end of my presentation.
Go back. I just wanna see something like the
That
related.
was beautiful.
That was really good.
I want to see like what exactly are they measuring the
What's
equivalence
your
point
name?
in?
Sorry.
The equivalence point in the second derivative is exactly the.
No, I'm trying to see like the units that they measure it in because like I'm just confused.
This is
about the-
volume.
It's measured in volume.
Yes.
X is the volume of the tetra.
Okay. Okay. That's. So we still have to do the math to find out like the actual like.
Exactly.
Okay.
That's the idea. Okay. Thank you.
Thank you.
If you need to make us, they are asking for help, you can request for a payment because this is not free for you. This is extra credit for you.
Yes, you gotta give her like 20 points extra credit on the test, like 15